Overfitting is a common challenge in deep learning, where a neural network performs well on training data but struggles with new, unseen data. One effective technique to combat this is dropout, a regularization method that prevents overfitting by randomly dropping nodes in a neural network during training. This article will explain dropout, why it's useful, and how it works, with simple examples to guide you through the concept. Imagine you're learning math and practicing with the same set of questions every day. Over time, you'd become very good at solving these specific problems, but if given a new problem, you might struggle. This is similar to overfitting in neural networks. They perform well on the data they've seen during training but fail to generalize to new data. Overfitting in neural networks happens because of the network's complexity. Multiple layers and nodes, all capturing intricate patterns. When overfitting, a model can memorize noise or irrelevant patterns, which doesn't help when it encounters new data. Dropout is a technique that randomly disables or drops a fraction of neurons during each training iteration. This prevents the network from becoming too dependent on certain nodes and encourages it to learn more generalized features, which helps it perform better on new data. To better understand, let's compare a neural network using dropout to a group study session where different students, or neurons, are randomly asked to leave the room during each session. The remaining students must still work together to solve problems, which strengthens each person's understanding of the material. During training at each training iteration, dropout randomly disables a fraction, say 50% of neurons in the network. This effectively creates a new, smaller neural network with fewer neurons for that iteration. As a result, the model learns to work without depending on any one specific neuron, which reduces overfitting. During testing or inference, when the model is predicting on new data, all neurons are active. However, the weights of the neurons are scaled down by the dropout rate to account for the different training structure. This scaling is typically by a factor of 1 minus the dropout rate to ensure the same output range as during training. For example, if you set a dropout rate of 0.5 during training, half of the neurons are disabled in each iteration. In testing, all neurons are active, but each neuron's output is multiplied by 0.5 to balance the network's response. Let's look at a simple neural network with 3 layers: an input layer, a hidden layer with 4 neurons, and an output layer. Suppose we set the dropout rate at 0.5. Epoch 1, 2 neurons in the hidden layer are randomly disabled. Epoch 2, a different set of neurons might be disabled, such as 1 neuron in the input layer and 1 in the hidden layer. Epoch 3, again, a different configuration of active neurons is used. Each epoch has a unique configuration of active and inactive neurons, which means the network is training in a slightly different way each time. Over multiple epochs, this randomness leads to a robust model that doesn't rely on any single neuron. By randomly disabling neurons, dropout effectively trains multiple subnetworks within the main network, which makes the overall model more adaptable and prevents it from memorizing specific data points, also known as overfitting. This technique has shown to improve model accuracy by up to 2%, especially on complex datasets. In random forests, multiple decision trees are trained on different subsets of data. The final output is the majority vote or average of these trees. Dropout works similarly by creating different subnetworks and averaging their learned features, leading to a well-rounded model that performs better on new data. Choosing dropout rate, common dropout rates range from 0.2 to 0.5. A higher dropout rate may be beneficial in very complex networks with many layers, while a lower rate is better for simpler models. Using dropout with other regularization, dropout is often combined with other regularization methods like L2 regularization to further improve performance. Early stopping track model performance during training to determine when it starts to overfit. Early stopping allows you to halt training at the optimal point, preventing unnecessary overfitting. Dropout is a powerful tool in deep learning, helping neural networks generalize better on unseen data. By randomly disabling neurons during training, it creates a more flexible model structure and reduces the risk of overfitting. Whether you're working with image classification, language processing, or any other domain, incorporating Dropout in your neural networks can lead to significant performance improvements.